Hey guys, so I'm going to help you with a couple of problems on day 10 supplement. First of all, let's look at what we're going to graph. We're going to find the area of the first four problems. It's all this cardioid. Remember, 4 plus, or a number plus cosine of theta or sine of theta is a cardioid, and the domain of that is 0 to 2 pi. Remember all the functions that I gave you on day 10 notes that you needed to know the domain and kind of what they look like. So we know this is going to be a heart when we graph it, so I picked ordered pairs that we could find easily. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I plug them in, cosine of 0 is 1, 1 times 3 is 3, plus 4 is 7. Cosine of pi over 2 is 0, times anything is 0, plus 4 is 4. Pi, cosine of pi is negative 1, times 3 is negative 3, plus 4 is 1. And then 3 pi over 2 is 0 again, so I get 4, and 2 pi is the same as 0, which is 7. So I'm going to go to my picture. Here is the 0, and I'm going to go out 7. Then pi over 2 is here, so I'm going to go out 4. I'm just going to connect them. Boop. Not real pretty, but here we go. And then pi is out 1. We're going to go like that. This is the pi over 3 pi over 2, so we're going to go out 4, connect it, and then back to, so it looks like a heart. Now, not a beautiful heart, but it's a heart. Now, because this one we're finding the area between 0 and pi over 2, that's the area of the whole thing. Our formula is 1/2 the integral from theta 1 to theta 2, which is 0 to 2 pi, of r squared, which for us is 4 plus 3 cosine of theta, squared d theta. I need you to plug this into your TI 89 and or 84 to make sure that you can get the answer. The answer is 64.403 rounded to 3 decimals, which AP always says you have to do. Now, if this was a multiple choice and it just had the setup, this is not the only way you could have done it. Because this thing is symmetric about the x-axis, instead of doing from 0 to 2 pi, I could have done 0 to pi. Now, that would have been 1/2 the integral from 0 to pi of 4 plus 3 cosine of theta squared d theta. But because that's only going to give me half the area, just multiply this by 2 to get all the area. And so the integral from 0 to pi of r squared d theta could have been an answer in the multiple choice. Please check and make sure you get the same answer using your calculator. Now, I've already graphed the other three. I want you to look and see what the difference is when you're finding the area. What you need to understand is you're doing straight lines. So if I do an example in the second one, pi over 2 to 3 pi over 2, here I'm starting at the origin. Pi over 2 is up here, and then this is my picture. This is my picture to 3 pi over 2. It's a straight line here. So this is going to be what I'm finding the area of. So it should be much smaller than the example for part 1. Again, our formula, 1/2 the integral from pi over 2 to 3 pi over 2 of RR, which is 4 plus 3 cosine of theta squared d theta. This one should give you 8.201. Again, it's symmetric, so you could also have gotten the answer when you multiplied it by 2. You could have done again 1/2 the integral from pi over 2 to pi of that r squared at the top, d theta. And then if you multiplied that by 2, so the integral from pi over 2 to pi of 4 plus 3 cosine of theta squared d theta should also have worked. So plug them both into your calculator, make sure they work. I'm going to post the answer key, but I'm going to show you what the other ones look like. Again, straight lines, straight lines, straight lines. So if you look at problem 3, pi over 4 is directly in the middle. There's 1, 2, 3, 4, 5. So it's straight line. Straight line, so you're finding the area of this region. Like I said, set it up, plug it into your calculator. The answer key will also be on the blog. And then look at the next one. Negative pi over 2. Boop, boop, boop. To positive pi over 2 is here. So you're finding the back half of your cardioid this time. Straight line to straight line. Again, set it up. Integrate it in your calculator. But remember, you're on your notes, I showed you how to integrate these by hand. So practice at least one of these by hand as well. Now, problem 5, I went ahead and found the values, and I thought I'd go ahead and graph it for you. So at 0, we're going to start at 5, and then as we go to pi over 4, it's going to go back to 0. And then at pi over 2, pi over 2 is going to negative 5, so it's going down. And then 3 pi over 4, it's going back to 0. At pi, it's out to 5, then back to 0. Then at 3 pi over 2, it's going to negative 5, so it's going backwards. Then back to 0. And then 2 pi is back to, so I've graphed. Remember, this is a rows. If it's an even number, you have the double the petals, and it's 0 to 2 pi. If it had been 3 theta, it would have had 3 petals, and it would have only taken 0 to pi to get there. Again, looking back at your notes, making sure that you kind of know what they look like. Now, if I just need to find 1, I'm just going to go from 0 to 0. So what I'm going to do is I'm going to use this theta value to this theta value. Now, I could do the whole thing from 0. I could do the whole thing and then just multiply it by 1/4 out front. But I'm going to do 1/2 the integral from pi over 4 to 3 pi over 4. And our r this time is 5 cosine of 2 theta squared d theta. Again, plug it into your calculator and make sure you get the answer of 9.817. Okay, I'm going to post all of these answers. I just wanted you to see some of them worked. I'm going to have separate videos for 2 of the problems on the back. Thanks.